Is immutable Linux really that immutable? Today we're gonna learn that it's not. You can actually use Universal Blue's custom image template, and you can install whatever you need on your own custom image and switch to it with Bootc. Let's dive in. So first, let's take a look at some file system basics. We need to understand how the file system changes for Bootc images, so we know where to install stuff. And the mindset changes slightly from what you do as a regular user. So for instance, as a regular user, you will install stuff under /opt sometimes, but for Bootc images you need to take care and make sure that /opt is immutable. So let's take a look at the root file system. As you can see, there are several symlinks here. For instance, opt is a symlink to var opt, and home is also a symlink to var home. And for anything that is defined under var, as a rule, you should not install anything during build time on your own custom image to these directories, because these are user controlled. Okay, if you look at user, you'll also notice that user local is a symlink to var user local, where user local is a single word here. At first, as I was building my custom image, I tried installing stuff to /user local directory directly, and also then I tried to install stuff to var user local, but none of this works. And it makes sense that you are not the user during build time, you are the maintainer of the operating system. So you should be able to install anything that you need under /user directly. So for instance, one thing that we installed was /user share uv tools. So we've got some system-wide scripts, Python tools that we install under user share uv tools. If I were installing this as a regular user, I would probably have installed this under /opt uv. Okay, so the mindset changes. Keep this in mind when you are building your image. But now let's get into the custom image template by Universal Blue, where we'll get into all of these details, hands-on. So if you want to create your own custom image, you could just create your own container file and start working on it based on the Bazzite NVIDIA open image or the Bazzite image. But instead, what is better for you to do is to use their custom image, which you can find at github.com/ublueos image template. Okay. And in here you'll find the complete instruction set on how to configure this. They even provide a video that is quite useful as well. You'll need to install the cosign tool, which is a container signing tool, and you need to generate this key pair. You will commit the public key to the repo, and you will set up your private key as a secret under your GitHub repo. So they have instructions for all of this here. I don't need to go into this, that you'll set this signing secret variable with the contents of cosign key. Okay, and the build process is handled automatically by CI/CD, so they've got their workflow here for building, and they will take care of everything. You just need to edit a few variables here, I believe. As you can see, you'll find image description. You can fill this in. You can add image keywords if you like. You can add a link to the image logo that is different from the one they provide by default, but I don't think you should touch this last three. I didn't change this for my image. If you go into the image templates, the entry point will be the container file. The container file copies all files from build files. Make sure to set this to the base image that you are already using for your Bazzite. For me, it was NVIDIA Open Stable. Okay. Then optionally, you can remove the OPT sim link, and that's why I was just talking about file system. If you want an immutable OPT, you can have it. Just remove it and recreate it as a directory. I ended up not using this. I explored it, but then I didn't use it. And then you've got a run command that calls a build script. This is called from /context, but this is really the slash directory from this scratch layer over here. And then they mount var cache, var log as cache. This is useful for debugging, for instance. And they also mount /tmp as a tmpfs, which is an in-memory file system. And then they run bootc container lint, and this is what blesses this container as a bootc image, I believe. There are a few things that they don't show here. So you'll get your build files here. By default, you've got a single script. This is one that is called. And if you need to install any package, you can do so here as a regular bash script, okay? Enable podman socket system-wide. This is, you know, the equivalent as the root user. So keep that in mind. But there's something that they don't show you here, particularly how to copy system files into your root file system or some other details. So let's take a look instead at our DLT OS image, which is our custom image. As you can see, this repo was generated from the UBlue image. If you want to do that, just come here and if I zoom out a bit, we'll find, all right, I need to be logged in for this to work, but you'll find a button here where you can click to use this template and just create a new repo based on this template, which is what I did here. And then I added 2 new directories, and that's what I wanted to show you. So you usually use the system files directory to drop files under your root file system that you want to copy. For instance, I've got etc neri config kdl, which will get copied to my system's image, my custom image, and it will be on my operating system when I boot it after I switch with bootc. And then I also have user bin, where I've got my custom Docker and Docker Compose scripts, as well as this tray launch, which helps with starting software that opens tray icons on the Neri. Sometimes there is a delay, and this fixes it, but we'll get into that next video. I'll go into all of the details on how I configured Neri and Octalia, so this is not for today. This was really what I was trying to accomplish when I first started working on my custom image, because that's something you cannot do with the distro box. You can install all the tools that you need, but if anything is system wide, like the window manager or the compositor, you need to do it this way. And so another thing that I added was repo files with my own logo. And if you go into the build workflow, you'll see that I changed the description, I added some keywords, and I switched the system logo to a link directly to this repo files file. And this is what makes the logo appear on Artifact Hub if you use it. So there is this config that is optional here called Artifact Hub repo YAML. If you want to list your image on Artifact Hub, let's just go into Artifact Hub, not this one, Artifact Hub. Let me just search for it. It's .io. If you search for DLT OS, you'll see that it appears here, and it's got its own custom avatar. And the README will be copied over here. The keywords are displayed here as well. And if you want this custom icon and this to appear here, you need to register for Artifact Hub, create a repo, then the repo will give you an ID, and you just edit this file and drop your own ID over here. and fill in these details. Keep in mind that this is public data, so use an email that you can use publicly. For me, it's this mail@datalabtechTV.com, which is public on my website anyway. Also, make sure that you register for Artifact Hub with this same email, so it knows that you have ownership of this repo. Okay. And so once you've got this working, then you'll be able to just run this command bootc switch, and then you add your own image here. For me, it's, you know, it will be by default, it will be stored under GitHub container registry, so ghcr.io. This should be the same for you if you are using the template. And then your username, lowercase, / your image name and the version that you want to install. For me, it will always be latest. This is the default one. They also keep ones with date, you know, so I could eventually switch to something like this, or even in this format. And you can as well tag manually as usual in GitHub, just to create your own stable version, for instance, and let me know if you want to use this and want a stable version. And by the way, keep in mind that we only have an image for NVIDIA, Bazzite NVIDIA Open. So if you're not running on a system with a NVIDIA GPU, then our image will not work. In the future, I'll try to add more options, and let me know if you are interested in trying it out and you are running AMD, because I will look into it and you know, add the proper instructions to build GitHub Actions, so we can build also an image based on AMD, the regular one. Then once you have done bootc switch, you reboot your system and you will be on the new image, our custom image. If you want to upgrade, just run sudo bootc upgrade, and this will download the latest version and upgrade it. By default, when the image is built, you'll find it in the packages over here, and it will use the tags latest dot and the date, and also the timestamp with the date. Okay. And all versions will be kept, so for previous dates, and every day this will be built, a new version will be built. So if you go into the workflow, you'll check that there is a schedule here for 10:15 a.m. UTC every day for the build to run. And this ensures that your own custom image will get all updates from the base image, so you'll be getting all updates from Bazzite as well every day after 10:05. Okay, so let's take a look at DLT OS, okay, the custom image based on Bazzite. As you can see here, I use Bazzite NVIDIA Open Stable as my base image. And I also split this into multiple runs, although currently this is really doing nothing for me, but I'm thinking about how to improve build performance in the future. So if you are experienced with creating Docker images, you'll know that if you change the image on the bottom layer, so the last commands, the image will have cache for the previous layers, and so it will be much faster to rebuild it. Currently I haven't been able to achieve this yet, but I'm trying to prepare for it. There are some details that I still don't know how to address. So if you go into the build YAML, you'll see that they are using Builda, which is a Red Hat tool to build the image, and I'm not sure how to add cache from, cache to, you know, to this. So as you know, this runs in a container within GitHub, so there is this is usually a Ubuntu runner, and so it will not keep state, so it doesn't have any cache for my layers. The one way to be able to achieve that is with these arguments that you usually pass to Docker, which are cache from and cache to, and you usually just create another image tagged with the name cache instead of latest, you know, and you use that image as your cache for future builds. But I haven't been able to understand that. Then there is another issue, which is when you run Bootc upgrade. If you just added a very small change to your custom image, like installing you know, a package that is, let's say, 100 megabytes, when you run Bootc upgrade, you'll still get the upgrade to download, let's say, 4 gigs, your whole layer set, your whole changes on top of the base image. And this, I believe, is due to DNF cache or metadata constantly changing from build to build. And so from what some people told me on the Discord for Universal Blue, I should look into DNF cache for this, and that's something I will address in the future. But for now, please know that the image will take full time to build regardless of the change that you do. And also know that once you run Bootc upgrade, you'll download all the changes every time regardless of the size of the change that you are doing this. Here there is something called rechunking, but I believe this is legacy now. I mean, from this name, I believe this is largely abandoned. And I've tried this, it doesn't work just by uncommenting, so I could try, you know, to fix this somehow, but I'm still not sure how to address this. But in the future I'll try to make it, you know, higher performance both for build and upgrade. So please just know at this point that this is something that happens, and if you are trying to build your custom image, try to minimize the number of builds that you do manually. Do all your changes in a go and test a lot of image updates that you do in one go to avoid, you know, constantly rebuilding on GitHub and constantly having to download 4 gigs from GitHub or whatever the size is for you. Okay, and now let's take a look at the DLT OS custom image. I'll show you what I did here. And so if you watched my video on DistroBox, every tool that I installed using DistroBox, I now moved to the base system here as DLT OS, and I also installed Neri and Noctalia, which is the main reason why I really wanted to do a custom image. But since I was working on the custom image, I also installed all the tools that I usually use here, and it's also a good exercise to learn about, you know, the quirks for building a custom Bootc image. And so as you can see, I've got multiple scripts here being called, and I also copy the system files to slash at the end. Like I showed you, there's the Neri config and a few bins here, some scripts, and I then validate the Neri config after I copy the file to the file system. This is to ensure in the future, currently not working, but in the future, that once I change the Neri config, I won't need to rebuild everything else. I just check whether the config is valid, and everything else should be cached. I mean, that's the idea. I'm not sure if this is even possible, you know, with this workflow. But now let's take a look at the scripts. The way this is organized is I've got a bunch of environment only scripts, one for Go, one for Cargo, and one for UV. And then I've got my base system script, and all the other scripts are essentially software bundles per category. So let's take a look at, for instance, the Go script. As you can see, we changed the go bin path to user bin, because now we are working from the maintainer perspective. And so, as you know, when you build a Go binary, it's a single binary. There's usually nothing else to install. So it will just copy the binary to user bin. This is extremely clean. I also changed the path for Go path and Go cache to point to var cache, because this is something that we've got here mounted as type cache. I'm just trying to connect the pieces, although this is not fully used still. And then I ensure that these directories exist. Of course, user bin should already exist, but this will do nothing unless it's a symlink. And if you are trying to copy stuff to directories that are symlinks, then you'll get an error here. It will complain that the file already exists and the file is the symlink. Okay, so take that as an indication. We do something similar for cargo, so we move our cargo home to var cache, and our cargo install root will be under user. And we do something slightly different but also similar for UV, because UV will install more than just a binary. We move the cache to var cache UV. Okay, this is quite standard. But then we also have to set the UV tool dir, and we set it to user share UV. If I was doing this from the viewpoint of a regular user, I probably use OPT here. Okay, but keep in mind, in immutable images, this is a better approach. And then we set UV tool bin dir to user bin, so that the scripts are symlinked there, our UV tools. And we set UV link mode to copy to avoid, symlinking everything. And this will let you install tools, system-wide tools, easily with Go, Cargo, so Rust, and UV, Python. Okay, so the usual way that we do this system-wide is either through packages in the system, sometimes they don't exist, or we use pip install with something that is global. I opted to use this limbo approach. That is not really the approach from an OS's maintainer, or the pure approach from a user. So this is mid ground. I opted to do this because I feel like these images are also mid-level between a full-blown OS maintainer or package maintainer and a regular user. So I think it makes sense to make it possible for us to use UV tool install easily for our custom image. So if you need this, you can just fork it and replace all these scripts with whatever you want. So for the base system, we've got this script. These flags are important, so if any of these commands fails, the script will exit and fail as well. So make sure to set all of these. These are good defaults. They are on the default build script as well. And so what I do here is I prepare the base system to run Neri and Noctalia. I removed the XWayland video bridge because this has been deprecated, and once I boot it into Noctalia, an empty window will pop up with this. So I ended up doing some research, and it seems this is not even required anymore, so I just remove it. I also installed the XDG desktop portal for GNOME. This is required if you want to capture your desktop correctly on OBS. So Neri supports the GNOME portals, and we are trying to reuse KDE here, so we haven't uninstalled KDE. If you wanted to do that, from what I understand, it's better to do it using the GNOME base image instead of the KDE image. You just uninstall GNOME and you've got a clean base image. It's easier to uninstall GNOME. So we also install Qt6CT, which is an utility that lets you manage themes without needing to go into KDE. We install a bunch of utilities like WEV, which captures keyboard and mouse events, so you know which keys are being activated when you press a media key or something like that. WL Sunset is a requirement for Noctalia for night mode. Keva is used for those cool, you know, audio visualizers, and PlayCTL helps me start, stop, next, and previous on my Spotify. You just, you know, configure Neri keybinds for this, and it's a go. Then we enable the community projects repo for Neri. This is the official one. We install Neri and we disable it. By default, it is recommended that on your images you disable any custom repos after you use them. So I follow that recommendation. For Noctalia, this is available in Terra. Terra is available on Bazzite but disabled by default, so we just run it with this enable repo Terra to temporarily enable the repo and install the Noctalia shell. Okay, and this is our base system. Everything else we've got here are, you know, user packages, common user packages. So let's go in order. So we first run base, then we install the languages. And if we go in here, because sometimes we'll need Cargo or Go to install some system-wide utilities, so this should be installed as soon as possible. And as you can see here, we are loading these goenv and cargoenv scripts because we run go install and cargo install here, and with these settings they will be installing Go PLS or shell format system-wide, and just LSP also system-wide. And as you can see, we just install Golang, Cargo, UV, Node.js, it's also available on our system, and then we install the linter for Go and the debugger for Go, and we install a few Go utilities that are not available on DNF directly, or at least I believe they are not. And next we go into shell utilities, and we do something similar. We install Starship for our prompt, we install Shimwa for managing our dot files, and please check the dot files repo on github.com/datalabtech.tv. You'll find my dot files there. We install DIRENV for automatically loading env files. We install the Kitty terminal, and then we install Zoxide, which is a CD replacement, BAT, which is a syntax highlight replacement for cat, ripgrep, recursive grep, FD, an easier file finder for the terminal. Then we install ESA, which is a replacement for LS. We install it using Cargo because it's not on the repos for Fedora. It used to be, but it's not anymore. And then we install some other stuff, you know, NCDU and the H encryption tools. Then we install network utilities, and let's go a bit faster through these. Stuff like netcat, mkcert, iperf, prettyping, and then some S3 clients, because as you know, we've created Live Store, and so we work a lot with S3 stuff, and this is useful for us. We also install HTTP with SIGV4 extension. And so next we've got our graphics utilities. We just install some libs so that we are able to convert iOS photos to JPEG or something like that with ImageMagick. And also this is a little tip: you can use this RamBG to remove the background from your photos. It will be available on DLT OS by default, and you can install it with the UV tool as well, like this. Then we've got our development tools. We install Precommit, CLock, Delta, NeoVim. we remove Vim Enhanced, which is the default Vim package, and we replace our system-wide Vim with NeoVim. Some people might like that, some people might not. This is my personal preference, so I just used it. I want to, you know, sudo edit stuff with my NeoVim, not the regular Vim. And then I install also LazyGit and Hugo. This is a pin to an older version that I need, but if you want to, you know, fork the repo, you can just replace this with latest. Then we've got our container tools. For our container tools, we install Docker CLI and Docker Compose Switch. Switch is not, you know, a Docker Compose switcher. It's just the new package. The older one is deprecated, and they are going to switch to this new package. Okay, so this actually installs Docker Compose. This installs the Docker command, and then once I install them, I move these commands to .real because I'm going to use them in my custom scripts in here. So I will be calling Docker real from here. But it will be wrapped with this Docker host variable set to your Podman sock. So whenever you run Docker PS or whatever, you are really running it on top of Podman. Okay, it's the same thing for Docker Compose. Then I install Lazy Docker and I install Cosign, which I needed to create the key pairs for signing this custom image. Then we've got some AI and data tools. So for our AI tools, I'm just installing Ollama here. So you'll get in DLT OS, you'll get Ollama installed by default. You can just run Ollama serve and Ollama pull for your models or run. And we've got a few data tools as well. We've got SQLite installed by default. We've got Miller for querying CSV files from the command line, YQ because JQ is already installed to parse JSON, and we also want to be able to parse YAML. We've got GNU plot for command line plotting, chart plotting, and we installed as well DuckDB, term graph for plotting charts in your command line, and Vizidata for exploring your data files interactively. It's a TUI. Okay, and then finally we've got the validations file, which just validates the NIRI config. If any of these fail, the build will fail. You'll get a notification, usually through email by default from GitHub, and you can check the logs to see if what caused the fail. Let's take a quick look at what you should expect when you push into the repo. So you'll be able to go into actions, and you'll notice that a new action has been triggered here. Let's, for instance, find one that has failed, so you can illustrate what happens when there is an error. So as you can see, and make sure you are logged in, otherwise you won't be able to see the logs for this. But and let me just zoom out a little bit. As you can see here, there is it was running my scripts, okay, and then it failed on this step. So I tried to remove the files under run and TMP. I was testing ways to improve the caching, make sure the layers are not changed with metadata. But this failed, and so I get an error, and I know exactly when it happened, and I can fix it from here. Whenever your image builds correctly, let's take a look. For instance, this was scheduled for today. When it builds correctly, then it will automatically log in to your GitHub container registry, push the image, and it will install Cosign and sign the image with your private key that should be set on your secrets. So for instance, you go to settings, you'll find secrets and variables and actions, and you should have a signing secret in here added with the contents of your cosign.pub key file, which is your private key. Okay, Your public key, on the other hand, will be committed to the repo in here. So this is public, you'll find it here. Once you do this, you can simply switch to the image and reboot. So it should be something like this, okay? Once you reboot, if there is an issue and you don't like it, you can always go back to the previous image. You can boot it from directly from grub as well. So if we run this, you'll find the current image as well as the previous image. For me, it's another DLT OS image, but if you are doing this the first time, it should be a Bazzite image. Let's say that you do this twice and you can't roll back to Bazzite, because you can also call roll back here and to go back to the previous image. You can always switch to Bazzite directly by running Bootc switch with YotLD and your Bazzite image stable here, and you will go back to regular Bazzite and you can undo everything that you did. Your system will remain bootable through all of this, and at worst case, if your system doesn't boot correctly because you messed up some config, you can just boot into the previous image and roll back, okay? So this is incredibly safe to work on and to explore. Don't be afraid to test it. And that's how you mutate an immutable OS. This is why the guys at Bazzite play around a lot with it's not really immutable. You'll find that they use square brackets around the IM before immutable. Also check out their talk on Scale 23 recent conference. It's on their Discord channel. They seem like really cool guys. Also the OGC people look like true tech people. So I'm really happy to see everything that's been happening with Bazzite, with Universal Blue, around Universal Blue, with OGC. This is extremely positive for the community. We are bringing in many people from Windows. You can actually game on Linux now, and Linux is becoming, the de facto operating system, and maybe this really is the year of the Linux desktop. And with the Linux desktop, you get everything for your workstation as well in one go. So it's really, for me personally, Bazzite and all this Bootc image cloud first approach to Linux is something that is really beautiful, and I am quite enjoying it so far, and I suggest that you try it out for yourself as well. Now you know how to build a custom image if you want to use something other than KDE or GNOME. Now you know how to switch to it. It's not that hard. Just create a repo from their image templates, go into build.sh and add your own commands there and go from there. As usual, you'll be able to find this week's blog post on datalabtechtv.com. You can follow the channel on Blue Sky or join Discord for a little chat. Don't forget to drop a like and subscribe to keep mastering systems.